ihasmath, and you're going to learn how to solve applied problems with parabolas. Parabolas can be used to model all sorts of things. The path of a bore when it travels through the air, the cross-section of a tunnel, a ditch, or water in a pipe, or arcs or bridges. In order to solve problems with such models, you usually need to use the features of the parabolas: the vertex, intercept, and symmetry. Let's have a look at some examples from old exam paper questions. You may want to pause the video here to have a chance to read the question yourself and think about what you would do. There is really no point starting a question before you understand what the variables are, so let's have a look. The first thing you notice here is that the equation uses an h instead of a y because it is used to model the height of the rope above the ground. X is the distance from the pole on the left, so if we translate this into a usual graph language, the left pole represents the y-axis. You should always sketch a parabola for these applied problems because it allows you to find the features. When I'm sketching the parabola, I don't care about accuracy. I just want to get the key features right. In this case, just really the symmetry to start with. The question is about the height off the ground that the rope is attached to the poles. What feature is this? Well, it's the y-intercept. How can I find this? Well, on the y-axis, x is equal to 0, and I can substitute this into the equation, which leaves me with h is equal to 6. For applied questions, always see whether you can interpret your answer in the context. I'm going to write the height is 6 meters. The second question scared a lot of students off, but really there is no need to freak out, just sketch it. In this case, we're starting with the y-intercept and another point at 8,5. We also know that the parabola is symmetrical with a line of symmetry halfway between 0 and 8, so x is equal to 4. Finally, the lowest point is 1 meter above the ground. That's the vertex with coordinates 4, 1. I've got 3 points now, and I could use the regression function in the calculator to find the equation. That would be absolutely fine. I prefer having 4 points to be able to check the r squared, but it would still work. Instead of using the calculator, I want to use my understanding of parabolas to do the question. I know that the vertex is at 4, 1, so the vertex form of the equation is h is equal to a times x minus 4 squared plus 1, where a is a vertical stretch factor. I can substitute in one of the other points, and the y-intercept at 0, 5 is the easiest option. And after a bit of solving the algebra, I get h is equal to a quarter x minus 4 squared plus 1. This solving equations business is something that you can actually use your calculator for, and it's worth practicing this. If you're fine solving equations algebraically, you can always do that, but if you find this a little challenging, use a graphics calculator. This is how it works. Click Menu, Equa for equation. This should be an 8 for you. Then F3 for solver. If you see an equation already in there, delete it. Type in the equation, but instead of A, always use the x theta t button underneath the red alpha button for the unknown. Don't forget the equal sign, that's a shift exp, and any brackets. Once you're done, press the xe button twice. You need to do it twice. In this case I get 0.25 instead of a quarter, but that's the same thing. Okay, 2 more questions. Pause the video and read them, and if you want to try them yourself, give it a go. As always, I'm going to sketch the parabola first. It's in factorized form, and I can see the x-intercepts at 0 and 6. This means that the line of symmetry is halfway between the two at x is equal to 3. And there is a negative in front of the x squared, so the parabola is pretty sad. The maximum height is 2, so the vertex must be at 3, 2. Beautiful! We just need to find out the value of a, so we can substitute the coordinates of the vertex in for x and y and solve for a, which is 2 over 9. If you've used your calculator to solve this equation, make sure you write down the precise value rather than a rounded one. 0.2 with a dot on top of the 2 means this figure is repeating. In the last example, we're given a diagram, but it's not very helpful because it's in 3D and doesn't help us identify the features of the parabola clearly. In this case, always sketch a simple graph. X is defined as the distance from where the ball was kicked, which makes the y-axis, where the goalposts are, the line of symmetry. So -5 and 5 are the x-intercepts, and the vertex is the y-intercept at 0, 2.5. This means we could either use the factorized form or the vertex form of the equation, but you know me, I like the vector form, so h is equal to a times x squared plus 2.5, knowing that a will be negative because of the sad state of this parabola. Solving for a results in 0.1, and the equation is h is equal to -0.1 x squared plus 2.5. There you go. Applied questions tend to freak out some students because they don't know where to start. Here's the strategy. Start by carefully reading the questions so you understand the variables. Then sketch the parabola and use your understanding of its features to add more points. Finally, write down an equation either in vertex or factorized form with an unknown for the stretch factor, and find this unknown to write the equation. By the way, the two bottom questions were excellence questions back in the days, so if you can do those, you're doing really well. Finally, sometimes there are some follow-up questions about the height at a certain distance or vice versa. Simply think about what is given to you and substitute it into the equation.